This is the second set of notes about maps, and it's entitled Topographic Maps. Topographic maps are special maps that show elevation with contour lines. The three-dimensional information on a topographic map can show us landforms like hills, mountains, rifts, and valleys that were once created through geologic processes. The elevation of a geographic location is its height above or below sea level. On a topographic map, this could be measured in meters or feet. This map shows an island. The blue around it is water, and every line is a change in elevation. But that's pretty complicated. Let's look at the basics. So the contour lines connect points of equal elevation. So if this is a landscape and you're to walk along one of these lines, your elevation isn't changing. You're neither going uphill or downhill. If you're crossing the lines, going from the 700 to the 800 in a northeast direction, then you're going uphill. So contour lines are iso lines. Iso means the same. The contour interval is the difference in elevation between one contour line and the next contour line. The amount of change in elevation that occurs between each line is your contour interval. It could go up by 5, 10, 20, or 100, and that could be feet or meters. Sometimes that's given on the map. Sometimes it'll tell you in the margin what the contour interval is. Sometimes you have to calculate it. So here you're not given the contour interval, but it could be calculated. You're going from 700 to 800. And each line between there's five changes. So you'd subtract 800 minus 700 and then divide by 5. And you get 20, and then you could check your work. So you're starting at the 700, working your way up to 800, you go 720, 740, 760, 780, 800. So the contour interval on this map is 20. Index contours are the darker, heavier lines on the map that are used as a reference. We couldn't have done that calculation if we didn't have the dark lines that were labeled with their elevation. The elevation of your index contours is used to calculate the contour interval. Subtract the lower number from the larger number and then divide by 5 for the 5 changes in elevation that occur between the index contours. That's what I just did. So 800 minus 700 divided by 5, so that's 100 divided by 5, and you get 20. Each change in elevation is 20. And don't get tripped up because there's 4 lines between 700 and 800, but there's 5 changes in elevation. So what's the contour interval of this map? See if you can figure it out. How much does it go up each line? Pause the video if you need to. So there's some rules for reading topographic maps. You've got iso lines that connect points of equal elevation. They never cross. They always run parallel to one another. And the contour interval is always consistent. You need to know that if the contour lines are close together, you have steep slopes. That means you're going uphill quickly. If they're widely spaced, if they're not close together, then you have gentle slopes. You're changing elevation, but not very quickly. And 0 is always sea level. Hills are shown by circles. If there is no elevation info, the top of the hill is just above the last contour line. So on this one, you've got a contour interval of 10 meters that's given to you. And there's 2 peaks, 2 hills on either side of the creek. On the right side, the last contour interval is 350. On the left side, it doesn't get quite as high. It goes 310, 320, 330. So on the left side, that hill would be at least 330 meters high, although it could be up to 339.9 meters high. And then on the right side, the hill is at least 350 meters high, but it could be as high as 359.9 meters high. So it's less than 360, because if it were 360, there'd be another circle there. Another thing to see here is the creek the contour lines bend across it, those are always pointed upstream, and I'm about to get to that. So as contour lines, they bend as they cross a river, and they always point upstream. So the water's flowing in the opposite direction that the contour lines point. A contour or a topographic map can be used to create a profile image as well. The topographic map is your bird's eye view, your aerial view. And it shows you different elevations, and a profile is the side view. And using this method, you can construct the side view based on the aerial view. On this, you can see on the left side, you've got two peaks on the map. The one on the right is higher than the one on the left, and then you see that reflected in the profile as well. Hasher marks are small lines that cross over contour lines, showing a depression on the map, such as a sinkhole or a crater. So if you see these little lines, it's going down. We looked at this map earlier. What do you think the height is of point X? Well, if you figured out the contour interval on the last slide, this should be fairly easy. Or on the earlier slide, it's going up by 100. And X is going to be above the last contour line, which is 1600. But not quite 1700, because there'd be another circle if it was 1700. All right, calculating gradient, or the slope. It requires you to know the contour interval and the scale of distance on the map. From point A to point B, calculate the change in elevation by subtracting, and then from point A to point B, calculate the change in distance by measuring according to the scale. If you divide the change in elevation by the change in distance, that's how you get the gradient, which is slope, which is rise over run. How much does it change in elevation per the distance? So on this map, from C to D, the distance is approximately 2 miles. And the change in elevation is negative 500 feet. You're going from if you're going from C to D, you're going from 1500 to 1000, so that's minus 500 feet. To calculate the gradient, you divide the change in elevation by the distance, so that's minus 500 divided by 2, and you get negative 250 feet per mile. If you're just going to eyeball it, you can see that the steepest slope is where the lines are closest together, and the gentlest slope is where the lines are far apart. So if you were going to try to climb to the top of this hill, you might want to approach it from the northwest, because that has the gentlest slope. If you approach it from the northeast, it's going to be the hardest climb. See if on this map you can find the height of point A, and that's right on an index contour, so that should be pretty easy. The height of point B, so you need to figure out the contour interval in order to get that. And then what is the highest possible point on this map? See if you can do that on your own. Pause the video if you need to. And then this is the notes. Everything you were supposed to write down was in orange text. You can watch the video multiple times. You can pause it where you need to. You can pause it here. And then you can either handwrite it, type it up. If it's all on one slide, it'll look like this, or you can use multiple slides if you need to. There's also the fill in the blank option on the assignment. Have a great day.